and record. So the meeting today continues to be about R packages, and in particular about testing. So the issue associated to this meetup links to a book chapter in the R packages book, a chapter dedicated to testing. And also, well, to the data science incubator chapter, which I'm going to be kind of following along this meetup. And also to something that I forgot to mention before, this link here points to the demo package. So the package that we built together in the data science incubator last week lives here on to the GIS organization. And you can, go back to it if you want, or clone it and work with it. In case you want kind of to practice on your own, here is like a template for what we have been doing. So here we are in the data science incubator chapter dedicated to this issue of testing.
Sorry. Have you shared your screen?
Oh, I thought I did. Let me see. Obviously not. Share screen. Let's do here, share.
Perfect. Now we can see it.
Okay. So what I was before I was talking about this issue in the data science incubator repo, includes links to the book that is, that where I'm getting the information from, also to the data science incubator chapter that I'm going to be kind of walking through, and to the demo package, which is the package that contains the code that we have been kind of working last week, and we may do something there today as well. So now I click here, you should be seeing chapter 17. Is that okay?
Yep, we can see it.
Okay, great. So the first thing you would need to do if you want to set up testing in a package is to simply run the function use this, use this, that. So I'm going to demonstrate that in the RStudio Cloud project that we've been working last week. So last week we kind of left at a relatively good place. So we have run checks, and we confirmed that the data set that we included was correctly added. And now all I've done is basically create a new branch with the function pinit max minus min, which is the name of the function I will be kind of working with today. So this is kind of pretty much kind of taking on from where we left last week. So I'm now going to clean the console, and I'm going to run simply use this, use this, that. Before I do that, I want to show you that my files do not contain a folder called tests. So the folder test does not exist here. But when I run the function use this, that, among a bunch of things, one thing that function does is to add such a folder. It adds the folder tests, and already includes a file that attaches the package test that and the package that we're working with, and also adds this subfolder called test that. And here is where every new test that we write is going to live. So I'm talking about this because it's kind of important to understand where or what is what the structure of the tests looks like in a package, because one goal of this presentation is to make you familiar with what you would see if you contribute to someone else's code. So if you contribute to someone else's code, you land in a project like the one that you're seeing right now on screen. And one of the first things you might want to do is, to click that button, check that, we did before, to make sure that the package, before you even do anything, is at a good state. Because if something breaks, you want to know if something was broken before you started working or since then. And then the other thing you would like to start to do is to then run the this other menu here, test package. So when there is no infrastructure for tests, when there is, there's a few things that need to exist there for test that to work. And one thing that needs to be is like a test. So say that we want to write a new function, and one good way to write a new function is with the function use r, and then you write the name of the function you want to write. And let's say that we want to call it max minus min. That's going to be the name of our function. And here we write it. So max minus min is a function that takes a vector and say that we'll calculate the max of that vector, and then we do minus the mean of that vector. So this is a function I'm kind of coming up with. One easy way to create the infrastructure of this, the testing infrastructure for this function would be to go to the console and type use test. And if you are in the active file for which you want to create a test, you don't need to do anything else. Test will be clever enough to create the right test where it should. I think we did something like this when we were adding data last week. So far, if we click this, the file that has been created by test.dat, what we see is like a meaningless test. It's just like a template for us to understand what we should be doing. So let's replace this with something more meaningful. So we should add a title here for our test and some kind of expectation. But this is, to begin with, like a gist for what the infrastructure of a test is. So there is a test folder, as we discussed before. Within that, there is a test.dat folder, and within that folder, there is any number of files. So you would have at least one file for each like exported function, for each function that users can use. So you notice now that the tests associated to the function max minus min the file starts with the name test dash, and that is compulsory, and test.dat does that automatically for you. So the tests prefix tells test.dat that is a test file, and it has to do special things with it. And then within that file, which is what we are seeing now on screen, there is what's called tests. You can have many tests, like this is one test and this is another test. And within each test, you can have many expectations. This is one expectation, this is another expectation. For now, they are all the same, but of course, you could write different expectations to test for different things. So that is all that I needed to kind of discuss about the basic structure of a test. So you know now how to set it up, you know what the structure looks like, and the workflow that this infrastructure allows is pretty simple. Basically, you modify your test code, you modify your code or your tests, for example, by extending your function or by creating a new function. Then you just run all the tests and see if they pass or if they fail. There's a convenient shortcut, Control or Command Shift and T runs the function DevTools test. So that is what actually is happening when you press this keyboard shortcut. And if the tests don't pass, then you continue to change your test or your code until they do. So let me kind of show you some examples of, for example, how we would go about testing this function that we just wrote, max minus min. So I'm going to remove this meaningless test, which were just for demonstration. I'm going to paste this test that is a bit more meaningful. So if I write, generally what we do is, we write a function and we test it on the console, right? So if we are here on the console, we would, first I'm going to load every object in this package with the function DevTools load all, and I do that with Shift Control L. And now, this function that I wrote should be available to me. So I'm going to try this function max minus min with the vector or the sequence of 2 to 1. So the maximum of the sequence 2 to 1 is 2, the minimum is 1. So if you rest 2 to 1, of course you get 1. So this could be one meaningful expectation, and tests look this silly, like for real, because the first thing that you want to test, to answer the question like what should I test? Well, the first thing you need to test is that what you think is true is actually true. You have to confirm like the silliest of the expectations. So you could do that with the minimum piece of data, like for example, this super tiny sequence. Let's do, actually here I meant to do this. So you want to test that this is equal to this, that if you take the maximum of this sequence, which is 2, and you raise it to the minimum of this sequence, which is 1, 2 minus 1 gives you 1. And you can also test that, for example, if you do the reverse of that, if the sequence 2 to 1, instead the sequence from 1 to 2, gives the same result. So that would be a meaningful expectation. And the title of this test should be something that if you see fail, it should give you a hint for what the problem is. So max minus min with simple good inputs return expected output. This could be like a meaningful test to run. So if you run the tests now, you should see everything green because the expectations are as you expected. But say that you expected that this second expectation should return true, should return 2, because 2 is not equal to the output of max minus min with the vector 2 to 1. Then this should return. If I run this test now, this should return a failure. So I run the test, and as you can see, I get a lot of useful information. I can read now the title that I wrote to myself. So the more meaningful the title is, the easier it's going to be for you when you run the test to know what was wrong. So I can read that in the test max minus min, in the row number 3, there is a failure, so exactly here. And the test title describes what the failure is. And I can see that the result is not equal to 2, and instead here is what the result was. So tests are a really quick way to help you, find bugs in the first place. Now, if you can kind of unmute yourselves, and so I have just kind of stated one of the benefits of writing tests is that it helps you find bugs, even bugs in your code or bugs in your test. But if I would like to ask you if you can think of any other potential benefits of having some tests, apart from bugs. Well, can you imagine any other way in which your tests could help?
They can make sure that when you add a function that the other functions still return what you expect. So if the package grows larger, everything still works as you expect it to work.
Great, that's a good point. So as you continue to add a new feature, you're saying that it's not only you confirm that this new feature works, but also you haven't broken anything that as a side effect of adding your new feature. Is that what you're saying?
Yeah, exactly.
Cool. Yeah, right. Any other idea?
I think it's super useful. Oh, hi, Mara. Honestly, I made it back.
Hi.
I think it's super useful when someone submits a bug report and you look at it and you realize this is a bug. Maybe it's not that your function was doing something wrong all the time, but it was like some edge case that you hadn't expected or something that caused us an error. And then when you submit the change to fix that in the function, it's really cool to add a test that also tests for this like edge case, because one is kind of a reminder to you that like that is something else that is important to your function, but then it also prevents that, at least that bug from ever happening again. And I feel like once you've resolved the bug, it would be kind of embarrassing if that got reintroduced at some time. So in the packages that I've worked with, I always try to do that if I was fixing a bug, like also add a test for that specific test case.
That's a great use of tests. I agree. Every test, every bug fix should come with a test that exposes first the bug, then you work towards fixing the bug, and then you leave the test there, because a lot of time it happens that if you don't do that, you end up that bug comes back again, and then you waste time. Basically, I could kind of summarize what you're saying, like, well, tests also help you save time by not spending time fixing bugs that you had already fixed before. Great. So those are excellent descriptions of why tests are important. And then, you know, in what to test, you know, I kind of covered the first and most basic answer to what to test, which is, you know, to confirm that what you think is true. But, you know, as CJ said, you know, there's other things that you can test, like, for example, edge cases. Like, when you're testing, you really change your mindset from, you know, making your best effort to write code that works. You change that mindset to making your best effort to break your code. So you have to become like someone very mean with your own code and try to break it. So we already covered the first thing, which is, you know, try to test something that works. So now we could try test something that is obviously wrong and should fail. So we should always also try to kind of prove to ourselves that what is expected to fail fails. So let's see how we you know, might go about that. So we can say something like, okay, let's see, this function max minus min with bad input throws an error. So that would be the test that I want to do here. And, you know, the package test that includes, in addition to the expectation expect equal, includes also the expectation, for example, expect error, and many other expectations too. But if I, for example, feed, so the object letters is just a sequence of letters from A to Z. So if I run, you know, a computation of, you know, the maximum of this object minus the minimum of this object, I expect an error. So let's see if what you know, I would get if I run that on the console. I would get this error that says non-numeric argument to binary operator. It is a horrible error message, very much not descriptive of what's going on, but I mean, good enough for now. You know, in the early stages of developing this function, I would be just happy to know that, you know, with this scenario, at least I get an error, and you can use a piece of the error message that you get and paste it here to see if the error that you get matches that piece that you wrote here. So I just added that test, and I'm going to run my test suite again. I'm going to run test package. Okay, I expect everything to go well. So if what you wrote here doesn't match, because I write something like that, so now this string doesn't match the actual error message, so I would expect the test to fail. With something that tells me that the expected match was what I wrote, but the actual match was different. So that's what you would see if that isn't right. So the last thing, sorry, did anyone say anything? I couldn't hear.
Just on that topic, I think it's good to mention that the match doesn't need to be perfect. For the error message, it's just like a regular expression.
Exactly, yeah. This is actually, the argument is called regex. Thank you. So you could say something like and you can do something like this. The asterisk there will match anything. And actually, I think it's this what I should.
I think you need a dot. Yeah, exactly.
Right. Let's see if that works. Okay. Yeah, it works. So basically, I'm matching none, then anything, any number of times, and then the word argument, something like that. So that's good because it makes your test flexible. There is better approaches to testing for errors, but it's kind of beyond the scope of the talk today. And then the last thing before we end, because it's time and also it's kind of about what I wanted to show today, is the edge cases that CJ mentioned. So this was like obviously right, this is obviously wrong, but then you have these very interesting edge cases where your thought about what the function should do is challenged. So for example, if I feed this function with, let's say, a missing value with an A, what do I get? Oh, okay, I get an A. And that kind of makes sense. So I could expect that, the output of max minus min with an A returns an A, which is what I got. So, I could write that expectation. But then what if, I give the function the vector 1, 2, and A? I mean, I would expect that, okay, the maximum of this seems to be 2, right? And the minimum 1. So I would expect that the output of that should be the difference between 2 and 1, and I would love to, the NA to be ignored. But instead, really, what I get is something different. So what we get is NA, because the NA kind of propagates and makes the whole thing to go NA. So if I run that test now, what I expected here is wrong, and I get the appropriate failure here. And this is, what brings us back to the beginning of the talk and to the end of the talk at the same time, where, well, now we are working with this testing workflow. So we detected that, a challenging edge case tells us that our function does not behave as we thought or as we think it should behave. So then we go back to our function, and maybe what we want to do is modify the function, something like NA equals remove equals true, right? So maybe this is what we really want. So we learned that we had to modify our function, and now with that modification in place, we can run the test again. And I still have the error there. So I don't know, I must be doing something wrong here, but this is the workflow. Basically, you learn that by challenging your function, by challenging your thought, you learn that your code isn't doing exactly what you think it's doing, and then you let's see if my test passed now. You modify your code or modify your test until the test pass. And then you're done. So the one great thing that tests have is that when the test passes, you're done. You know that you finished. You don't waste time, like making your code perfect and at the same time breaking things that used to work before. Okay, that's the end. Sorry that I was too long starting the talk. Do we have some questions before we finish? I typed some here for.
I have one comment and two questions, which maybe don't have to answer, but I just throw it out there. So the comment is like, yeah, I totally agree. This is super important for packages, particularly because you're generally creating functions to do something with a context that you don't necessarily know, and that makes it very easy to come across these bugs because it's hard to predict all of the context that it might be used in. So yeah, thumbs up for that. Then the questions were like using testing in other places. So for one, I was wondering if you have any experience using testing regime in like a non-package type project, like a data analysis project or something. I don't, so that's not like a trick question or anything.
Yeah.
And
I totally agree. Yeah. I totally agree that most people are probably in our organization are more interested in how to test your code when you don't want to kind of build the infrastructure of a test package. And you can. I mean, I at some point I was a heavy user of the assertion packages like assert R or assert that or assertive. There are several packages that come with a lot of assertions. So if you are not testing after the fact, one of the best things you can do is add a bunch of assertions, sprinkle in your scripts. Also, tests that can be used in a script, so you can still use in any script. You can always use functions from teststat by calling just the library. And you can say, if you build a function, you can always do like, you can say expect equal 1 to 1, and if this is sprinkled in your script, and the assertion doesn't fail, it will do nothing, and if the assertion does fail, it will get you an error. So yeah, I think that one good way to kind of get started with testing is like forget about the test package infrastructure and just start using the assertions like right away in your script. I think. Any other one has any other experience or idea about that?
Nope.
No.
Yeah.
And so my second question is like very much related to that. I also wonder about using, like you said, assertions or this test set package expectations in functions to test incoming arguments. And that's something I feel like is woefully underutilized in the R community.
Yeah.
And I think it's also pretty useful in R because the language of R, the way it like lazily loads arguments, I feel like it like really facilitates this case where you get through all this stuff in your function and then you realize one of the arguments that you passed is something totally unnecessary or totally wrong, and it causes all kinds of problems. Yeah, I wonder why that's not more commonplace.
Yeah.
And so
Yeah.
I would like to see functions, our functions or functions in general, testing these arguments for certain assertions before it even runs and starts doing, especially ones that do like a pretty heavy or long running process, to do some assertions beforehand and then give the user like some reasonable feedback, not like X is not an object of list, blah, 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 something that no one knows what it means.
Yeah.
So
As you speak,
yeah.
As you speak, you know, I'm kind of trying to capture in code, you know, your suggestions. X should be numeric. So this, you know, I don't know if everyone is familiar with the jargon assertion, but basically an assertion of an input argument, as CJ was describing. I think, correct me if I'm wrong, but if I'm interpreting your comment correctly, it's like, well, you know, instead of feeding, you know, this part of the code with a horrible input, say that the input X was, I don't know, the letter A. This is a horrible input that, you know, this code here will fail because it's a horrible input that, you know, this code doesn't know what to do with it. So instead you can catch that X earlier here with an assertion. Here you get an assertion that is, okay, moderately more informative, or you could, you know, do something a bit more laborious and test that if X is not numeric. So you do it kind of manually, right? Then you can write the message that you like. So yeah, this is totally underused, and I agree. One thing that I like including my test is like at least one test for each of the arguments to the functions to capture, just to see what is the message that you get from horrible inputs. So yeah, thanks, CJ. Absolutely, I also agree that that's totally underused, and I suspect that it is because people like having, you know, functions that are clean, like not contaminated with a lot of stuff before. But there's solutions to that. You know, you can extract this in a check X function, and then here you just call check X, and you move this function outside.
Mauro, I think we're cutting into Data Herald time now.
There you go.
Unfortunately.
Thank you very much. Goodbye, everyone.
So, thank you so much. Bye-bye.